Okay, we are moving on to our statistics unit, our central tendency, our data analysis unit. And we're going to start with central tendency. Your ICANN today, you can calculate mean, median, mode, and range given a data set. All of this is encompassed under measures of central tendency. That's like an umbrella term, a central tendency. Central, you think middle, it's the center. So it approximates the middle number. Measures of central tendency is a way to look at averages. And there are 3 ways that we can really look at the average. Actually, more like 4 ways that we can look at the average. You can look at it through the mean. And how you calculate mean, I tell my students you do mean math. The mean is when you do math. You got to add up the terms, add up and divide by the total terms. Numbers there are.
Can we write like average on the side?
Yeah. Central tendency, actually you could write it above central tendency because that's what it is. It's an average. It's a way to calculate the middle or average number. The median, you need to put it in order and then you cross out from the first to the last and you get to that middle number. But we call it from least to the greatest. And you alternate. Okay? Mode. Mode, I think most. It's the term that occurs the most. And range is your largest number. I'm just going to keep it simple. Big minus the smallest. Let's say biggest minus the smallest. Or largest. Or the maximum minus the minimum. All right, so all of these are a way to represent a middle number. And they all come up with a different, usually a slightly different middle number. And that's what we're going to be able to do today. We're going to be able to see which one is the best one to use for a particular situation. So given this table, looks like a readathon, pages read in 1 week. I always read the title of my tables. We want to find the mean, median, mode, and range. So the mean, we add up 40 plus 45 plus 48 plus 50 plus 50, and then divide by how many there are. There's 1, 2, 3, 4, 5, and 6.
You didn't add it.
You forgot 59.
Why did I forget 59? Oh, no. Good job. Good catch. And this is equal to 292 over 6. So you divide it by 6, which is I get 48.7. 48.7 is my mean. Mean math. Add up, divide. You have to do the most math with the mean. Median, put in order. Looks like they already are. I'm just going to rewrite them. 40, 45, 48, a 50, a 50, and a 59. And you cross out from least to greatest. And what happens when I have 2 numbers in the middle? What do I need to do, Xavier? Add them up and divide by 2. Or find the middle. Here I would just say, what's between 48 and 49? Or just kidding, 48 and 50 is 49. Notice, compare right now. My mean and my median are pretty close, right? They're both a way to represent that average number. Mode, what occurs the most? 50. Compare 50, 49, 48. Looks pretty similar. It's clustering. It's finding that middle term. And range, the biggest minus the smallest. So what do I got? 59 minus 40, which is 19. Okay.
On our assignment for me, are we gonna have to show our work?
Okay, so how I would expect to see your work on your homework for mean, I go ahead and find the sum right away in my calculator. I don't even worry about showing everything I add together. And the mean would be 17.7. I added them all up, divided by 1, 2, 3, 4, 5, and 6. 2.95. And I just check, is it reasonable? Does 2.95 look like it's right in between everything that's there? Yep. Okay, median, I put in order. So it looks like my smallest is 2.3. I have another 2.3. I have a 2.7. I have a 2.9, a 3.2, and a 4.3. And then I cross out from least to greatest. And what's in between 2.7 and 2.9?
2.8.
It looks like it's pretty similar to my mean. My median is close to my mean. My mode, what's my mode?
2.3.
2.3. I wouldn't say that would be a good measure of central tendency. 2.3 seems on the low end, not the average end, doesn't it? And my range, the big minus the small. So my big is 4.3 minus 2.3 is 2. Now, I'm not going to do the other examples with you. I think that you've been exposed to that plenty, but I want you to look at D. D is the biggie. We can still find an average with something that doesn't have a quantity next to it, like a numerical number. But how can I label fruit? There's no way, right? It would be a matter of opinion. What do you think, Christian?
You have to put like you know how you have
Assign a number, you're thinking?
you say you have 10 and then you put like a little letter or number in the bottom. So 10 in the bottom right corner you have a 1. And that's how
Okay,
you could label different
I could. So he's saying I can assign them some kind of value. But I want, without having to manipulate them at all, there's no way to order them. And everything that's going through your mind right now is just a possible way to assign a value to them. You can't. You can't assign a value to them. You don't know what they are. Because what I would assign a value, somebody else might assign a different value. So we need something to be constant. The only way to measure a middle ground for something that doesn't have a numerical value is to use mode. Mode is a way to represent an average number. It's how retailers know what to sell. Mode, just like think about pant types. Hollister, Arrow, Rue, American Eagle. Those are all pant types, and when you're thinking of, oh, what am I going to sell? Let's say that I work at a Target and I think, what should I sell to my consumers? I want to know what people buy. Well, I can't assign a value to these pants, so I have to see who purchases the most brand names, right? So mode is how we find that average number. So what occurs the most here?
Strawberry.
Strawberry with 3. So the mode would be strawberry. So the average person is going to choose strawberries. Next thing we have when we talk about data analysis and central tendency is a vocab word called outliers. And when you think outliers, you think outsider, someone who's like away from the group, okay? Outlier is a value that is far away from the other values or numbers. And they affect the mean. They really do. They totally affect the mean. Imagine if we said, let's find the average height of teachers. Well, do you think there's any outliers for teachers' height?
Yeah.
There's me,
Timmons.
right? No, I think I'm probably shorter than Timmons.
Yeah.
There's me, and then who's another outlier?
Hanson.
Hanson. So here we are, you got me, Hanson, okay, and we're like, let's find the average height. Well, that doesn't count because you're throwing us in the mix. Nobody's as little, well, there's some that are short like me, but not many people are as tall as Hanson. Volts is close. But we do affect the average height. So judging then the average height of a teacher is going to be skewed because you got me and Hanson in there, and that's just not the average situation, okay? So we can analyze how outliers affect the mean. What you do is find the mean width, and then you're going to take them out and find the mean without it, and then you take the difference. So you find the mean with it, find the mean without, take the... Okay, looking at this first data set, what's the outlier here? 31. So the outlier would be 31. Let's see, because it's far away from all the numbers. The numbers seem to be smushed together, and it's far away, okay? Let's see how it affects the mean. We got to find the mean with it. So we're going to add all the numbers up. Okay, so the sum with it is 92, and you would divide by 1, 2, 3, 4, 5, 6, and 7. And you get 13.1. To find the mean without, you just take out, I like to do it the easy way. I know the sum with it, I just take the outlier out, so I subtract 31 from it, and I get a sum of 61. Then I only have, if I don't have the outlier in there, then I have 6 terms. And we get 10.2. So how did it affect the mean? It affects the mean. I got to take that difference. 13.1 minus 10.2 is 2.9. So around 3. It affected the mean by 3. Okay, with this one, the outlier is 1. Our mean width is 89.5 divided by 1, 2, 3, 4, 5, and 6, which is 14.9. Without, well, I see that my outlier is 1, so I'm just going to take that away from the sum. That would be 88.5. I took a value away, so this should be 5. And that's 17.7. It affects the mean. You take their difference. .8, which isn't that bad. Dependent on what you're talking about, I guess. Okay, last page, quickly. To determine the best way to figure out the average number, there's some situations that occur. If you don't have outliers, if there's no outliers involved, which can happen, you can usually just tell if there's an outlier or not. It will just be like, oh yeah, that's totally out of the norm. But if there's none, you use the mean. That's the best way to represent the average. If there's outliers, you need to get rid of them. How can you get rid of them? Slash them out. Okay? Median. If they're not a number, what do you do? Mode. If they're not a number, you mode it out. What happens the most? Let's do some examples. This is what your homework will be like. They'll say, which measure of central tendency should you use? Favorite movie, what do you think? Mode. Because I don't know what number Pitch Perfect 2 is. Okay, I don't know what number that is. I can't put it in order. Allowance. Mean. I mean, could there be outliers? Some kids get nothing. Some kids get 20. Some kids get 5. Some kids get 3. I would say there's some outliers. Daily high temp. Depending on what time of year you're talking. If it's the same season, they're around the same number, you could do mean. But if it's year-wide, there's some.
Especially year-wide, it like gradually.
it gradually